Yesterday, we were in section 2.2, and we need to finish that today. And we were looking at limits. So we were writing something that looks like this. Limit as x approaches a of f of x equals L. And what did we say that symbol meant? What did that symbol mean? When the x number is getting close to some value a, f of x will get close to some value L. And what was a little shaky about that definition? The word close. We didn't really define what close meant. Generally what we did is we built tables, and if x was supposed to be getting close to 2, we used numbers like 1.9, 1.99, 1.999, 2.1, 2.01, 2.001. We figured those were close. Today what we're going to do is we're going to give the strict mathematical definition of close. And then we will actually prove that a limit is what we say it is. All right, so here's the strict definition of this symbol. Assume f of x is defined for some open interval containing a, except possibly at a. Then, the limit as x approaches a of f of x equals L means for every epsilon greater than 0, there exists a delta greater than 0 such that the absolute value of f of x minus L is less than epsilon whenever 0 is less than the absolute value of x minus a is less than delta. Well, most of those words look like English, but put together in that context, I'm not really sure what that says. What does that mean? Well, there's a couple Greek letters. That's always fun. Epsilon and delta, a couple Greek letters. That's a good thing. So what does this mean? Any thoughts? All right, here's what it says. It says you get to pick a number epsilon, any positive number you want. So if I claim that the limit as x approaches a of f of x equals L, you pick an epsilon. It's then up to me to find a delta so that when x is within delta units of a, f of x will be within epsilon units of L. All right, I don't think that helps very much. So let me give you a concrete example, somewhat concrete example. Your company has been hired to build spheres that must hold, I don't know, how big do you want your spheres to be? How much do they have to hold? A liter. If we use liters, that's going to cause some problems later on. I would accept something in cubic meters, because in a minute I want to relate it to radius. And I don't know off the top of my head how to convert liters to cubic meters. How many? 50 cubic meters. Can you build a sphere that will hold exactly 50 cubic meters? 50 cubic meters is a lot, by the way.
Somehow.
Can you build a sphere that will hold exactly 50 cubic meters? I don't think you can. I don't think you can. No matter how accurate your instrumentation is that you're using to build this sphere, I don't think you can build a sphere and guarantee that it will hold exactly 50 cubic meters. So you're going to be given a tolerance. So the company's going to say, we need a sphere that holds 50 cubic meters, but we're willing for it to be off by a little bit. How far off can our sphere be? 50 cubic meters. That's way off. That's usually when they want it to be off, they want it to be off by just a little bit.
2 cubic meters.
Okay, so we can be off by 2 cubic meters. The volume can differ by 2 cubic meters. How much can your radius vary? So now you're getting ready to build the sphere. You know you want the sphere to contain 50 cubic meters. So we can figure out exactly how much our radius should be. But then we know we can have a possible error of 2 cubic meters. So we could build our sphere a little bit too big or maybe a little bit too small. But how big and how small? Okay, so in this case, what you have done is you've told me epsilon has to be 2. My f of x, which is volume of the sphere, has to be within 2 cubic meters of L. So in other words, the volume minus L is supposed to be 50, has to be less than 2. So that's the symbol we use for close. Our volume must be within 2 units of 50. All right, I'm going to rewrite this inequality a little bit. Another way to rewrite this inequality is minus 2 is less than volume minus 50 is less than 2. Why is that the same inequality?
You just took out the absolute value signs. Because, I mean, before it just said that whatever value you got, you made it positive. You didn't make it positive. You just took the distance.
Correct. This symbol really means distance from 50. So what I'm saying is your distance from 50, you could be too bigger than 50, or you could be too smaller than 50. So what that tells us is, of course, we could have figured this out without writing these fancy inequality symbols, I think. When we get all done, our volume needs to be in between 48 cubic meters and 52 cubic meters. Okay, so this is our f of x minus L less than epsilon. So my job now as the engineer, I need to figure out the delta value. So I need to figure out how far off can my radius be. If my sphere has to be within 2 units by volume, how far can my radius be? All right, so I need a formula for volume. Anybody happen to know a formula for volume? Four-thirds pi r cubed is the formula for volume of a sphere. That is correct. So what this is telling me is 48 has to be less than 4 pi over 3 r cubed, less than 52. So now what I need to do is I need to get the r all by itself. How would you get the r all by itself? Multiply by 3 to get rid of the fraction, divide by 4 pi, and then you got to take the cube root. All right, so I'm going to use my calculator because I can't do that kind of arithmetic in my head. So 48 times 3 divided by 4 pi. Make sure when you use your calculator you put the 4 pi in parentheses. I guess I could put this here and show you. And then take the cube root. So that's a cube root is a power of 1/3. So on this side, I have, let's call it 2.2545 less than r less than 52 times 3 divided by 48. Cube root that. Oops, that's not right. 52 times 3 divided by 4 pi. Cube root that. 2.3155, I'll call it. All right, so in order to build the sphere that's going to match, we need our R value to end up being between 2.2545 and 2.3155. Ideally, what should our R value have been? If we wanted the sphere to have exactly a volume of 50, what should our radius be? 25. It's got to be between 2.25 and 2.31, so I don't think it can be 25. It's got to be between those two numbers. 2.75 is not in between those two numbers. 2.275 maybe? Well, we can figure it out, right? If the volume is supposed to be 50, then 4 pi over 3r cubed should be 50. So r should be, let's see, this would be 50 times 3 divided by 4 pi. Cube root 2.2854, we'll call it, rounding off to 4 decimal places. So our radius really should be 2.2854. But we know our radius could be as big as 2.3155 and still be within the required specs, or our radius could be as small as 2.2545 and still be within our required specs. So how big is the error? Let's see. 2.3155 minus 2.2854. So in order for our sphere to be in between 48 and 52 cubic meters, how far off can we be on our radius? 0.03 meters, which is 3 centimeters. So when we go to build this sphere, if we want it to be 50 cubic meters plus or minus 2, our radius has to be 2.2854 plus or minus 0.03. We can only be off by 3 centimeters, either too big or too small. So what's that 0.03? Back in this crazy definition of all these weird words. That's the delta value. What if I were to change the epsilon value? What if I said, my company's really, really picky, and you can't be within 2 cubic meters. I need you to be within a half of a cubic meter. Then what's going to happen to my delta number? It's going to get much, much smaller. Okay? So that's what we mean. By a limit, we mean once somebody picks that epsilon value, it's up to me to be able to prove that I can find that delta value that's going to work. All right, so let's look at the kind of problems you're going to be doing for homework now. The limit. As x approaches 2 of 3x minus 1 equals. Well, first off, can you tell me what that limit should equal? Give you a hint, it's very easy. Not 2.
0.
Not 0.
5.
Guess it wasn't that easy. 5! 5 should be the right answer. Why should 5 be the right answer?
Plug 2 in for x.
Can you plug 2 in for x in this problem?
Yes.
Yes, how come?
You're gonna denominate it, make it, yeah.
You don't get any division by 0. You don't have any issues like that, can you? In fact, that's just a linear equation. I can plug in any number I want. So yeah, I can go ahead and plug in 2. So the limit really should be 5. And if I were to build a table and use numbers like 1.9, 1.99, 1.999, 2.1, so on and so forth, I should really be able to convince myself that the answer is 5. But now we need to prove it. Okay? So, let's pick an epsilon value. Somebody give me an epsilon value. Epsilon is usually a small number. That's not a small number. 0.05. So we're going to let epsilon equal 0.05. Our goal is to find a delta so that f of x minus L is less than epsilon whenever x minus a is less than delta. Okay, so what's f of x in this problem? F of x is 3x minus 1. L is 5. Absolute value less than, what's epsilon? 0.05. Okay, and over here, x is x. What's a? 2. And delta is the thing we need to find, right? So somehow I need to start with the thing on the left and end up with the thing on the right. So what do I do? Inequality, you mean?
Yes.
Yes. Okay, so what I'm going to do is I'm going to rewrite this. I'm going to rewrite this as 3x minus 6 is less than 0.05. And then what can I do with that? I could split it. I don't really need to, though. Anybody got a better idea? That would work, but that's not what I'm going for. Factor out of 3. You can factor there, can't you? 3 factors out. And what do you get when you factor out of 3? X minus 2. And that happens to be a really nice thing. Why does it just so happen that x minus 2 is a really nice thing? Because that's what we were trying to get, wasn't it? So what James was doing would work. He was splitting the inequality like I did in the previous problem. That would work just fine, but in most cases you're not going to need to do that. In most cases you're simply going to be able to factor and it'll work right out. So x minus 2 should be less than 0.05 over 3. So that's going to be my delta number. So if I let delta be 0.05 over 3, then that will be close enough so that f of x minus L will be within that 0.05 that you told me it had to be. What if somebody else picked a different number for epsilon? Okay, so let's pick a different number for epsilon. Same problem. Give me a different number for epsilon. 0.25? Okay. If epsilon is 0.25, what should delta be? 0.25 over 3, that's your guess? That's an excellent guess, because I think it's correct. Let's see, f of x minus L, once again, less than epsilon, would be 3x minus 1 minus 5, less than 0.25. And then you really have the exact same thing, don't you? 3x minus 6, less than 0.25. Factor out the 3 and divide by it. X minus 2, less than 0.25 over 3. So if you decided that your tolerance is only 0.25, then the answer I would give you is, well, my tolerance for my x value has to be 0.25 over 3. What if you picked a different number for epsilon? What would the answer turn out to be? That over 3. How come?
Some number of 3, because what you're doing is you're basically, every time you get that equation, you're simplifying it to x minus 2, and whatever you do to simplify it to get x minus 2, you have to repeat and do it to your epsilon I to get delta.
Absolutely. If I pick a different epsilon number, is anything on the left-hand side going to change? No, the only thing that's going to change is the epsilon number. All right, so most of the times when we do these for homework, we're actually not going to have numbers. We're just going to leave it as the symbol epsilon. And we'll let anybody who wants to pick any number they want, and we'll work it out. All right, so here's what your homework problems are really going to look like. Limit. As x goes to, let's say, -4 this time of, I don't know, somebody give me a nice linear function. We just used 3x minus 1. Give me a different linear function. 2x plus 5 equals, all right, first off, tell me what that limit should equal. -3, and all you did is plug in the -4. So that limit should be -3. Okay, and now we're going to prove it. So start with f of x minus L less than epsilon, reduce to x minus a less than delta. And that will tell you what your delta value should be. All right, f of x minus L less than epsilon. In this problem, what is f of x? 2x plus 5. Minus, what's L? -3, that's our limit. Less than epsilon. And we need to get to x minus, what's a? -4 less than delta. Well, what can I do with the left-hand side? What's 2x plus 5 minus -3? 2x plus 8 less than epsilon. Factor out the 2. 2 times absolute value of x plus 4 less than epsilon. Absolute value of x plus 4 is less than epsilon over 2. And isn't that exactly what we wanted? X minus -4 is the same as x plus 4. So for this problem, delta better be epsilon over 2. So once you pick your epsilon number, no matter how big or how small you pick it for your acceptable tolerance, I'm going to tell you, well, my answer is half of that. And if my answer is half of whatever you give me, your tolerance will be met. Questions about that? All right, so tomorrow you have your take-home test due. So that will be the first thing I will collect tomorrow. And then the lab. The lab is due not this Tuesday, but the next Tuesday, and I think we said that was September 10th.
Yeah.
All right, so there's what you should be working on. Take-home quiz for tonight and your lab. And then once you get those done, well, the lab you can wait for a while. Once you get your take-home test done, you should start looking at 1.1 and 1.2. See you tomorrow.